Hey everybody, today's lesson is about multiplying polynomials. The last section that you had was about adding and subtracting polynomials or multiplying a polynomial by a monomials. We're going to talk about something different today, and there's going to be a little bit of a shift in the way we think. You're going to end up multiplying two things together with parentheses that look like this. These are called binomials, of course. Binomials have two terms, remember terms are separated by addition or subtraction. So this is a binomial a plus 2 and this is a binomial a minus 5. But there are other kinds of polynomials, binomials and trinomials and so forth. We're going to multiply these two together. But it's not like we just got done doing on multiplying monomials. Let's go over here. The old stuff that we just finished doing was multiplying monomials. And to multiply monomials, you multiply each number times a number, and the same variable times the same variable. In fact, let's change this to y. Change this to y squared. If we were to multiply this out, we'd go 10 times 3 is 30, x times x is x squared, and y times y squared is y to the third power. Now this is because these are monomials. They're monomials because there's no addition or subtraction signs in the problem. So this is the way we just finished working with monomials. But now with binomials, what we're going to find is that every term in here has to get multiplied times every term in the other one. So these two get multiplied, and these two get multiplied, and these two, and these two. Now let's show you why this works. We've been doing this since the beginning when you were learning to multiply numbers. Let's take a look at why it works. All right. When you learn to multiply two numbers together that were like two-digit numbers like this, you'll notice that we had a process that we used, and you may not realize it, but you always did 5 things. Okay? It may not seem like it, but you did 5 things altogether. And every digit got multiplied times every other digit. Now, we're going to do 5 things. It's going to be a little different than the way you usually used to do it, but we're going to do it anyway. Remember, this is the ones place. The 4 and the 6 are in the ones place, and the 2 and the 3 are in the tens place. So this 2 really represents 20, and this 3 really represents 30. So let's multiply every digit times every other digit. Here we go. 6 times 4 is 24. Usually we carry that 2, but we're just going to put it down here this time. And 6 times 2, well, that's really not 2, that's 20. 6 times 20 is 120. Okay? Now we're going to take 3, that's really not 3, that's 30. 30 times 4 is 120. And 30 times 20 is 600. 30 times 20, no, wait a minute, that's 30 times 20 is 6,000. 6,000, not 600. 6,000. 3 times 2 is 6. Oh, maybe it is 600. Yeah, it is 600 here, not 6,000. 600. So we've got 1, 2, 3, 4 things that we did, and then we added them up. And we just add these all together, and we get 864. Now, if you don't believe me, let's do it the way you used to always do it. So I did 4 things, plus I added them at the end. That's 5 things total. Let's do it the way you used to do it, and you were taught how to do this. Here we go. 6 times 4 is 24. Carry the 2. 6 times 2 is 12. Plus the 2 you carried is 14. We leave a space holder here. 3 times 4 is 12. Carry the 1. 3 times 2 is 6, plus the 1 we carried is 7. And when we add these up, we get the same answer, 864. Same answer. Okay? Now, really, what we ended up doing is we multiplied every number times every other number. Just to make a point here, let's do this a different way. Watch this. Okay? What if we wrote this 20 plus 4 and 30 plus 6? And this is the form that you're going to be in when you multiply polynomials. We're going to do it the same way we did it before. And I'm going to do it in a manner called FOIL, F-O-I-L. The first number in each group is F, in each group. The last number in each group we'll call L. The outsides would be these two on the outside, O, and I stands for the inside. First, outer, inner, and last. First, outer, inner, and last. First, outer, inner, and last. That's what FOIL stands for. First, outer, inner, and last. And if we multiply these together, we're looking for the number 864 because that's what we got before. So here we go. First, 20 times 30 is 600. Outer, 20 times 6 is 120. Inner, 30 times 4 is another 120. And last is 4 times 6 or 24. And again, you see that we get 864. What's the point here? The point is that when you have a binomial like this, you have to multiply every term times every other term. So now we're going to go ahead and do this with variables, and it's going to be the same process. There's 4 things to do by multiplying, and the 5th one is to add them all together. Let's try one. All right, let's try this one. And we're going to use that technique, first, outer, inner, last. And for now, I'm going to put letters up here. First, outer, inner, and last. After a while, you won't need to keep doing these. Let's start with the first. X times x is x squared. X times, outer now, x times a negative 3. See, there's a sign there. X times a negative 3 is a negative 3x. And then inner, positive 2 times x is 2x. And then last, 2 times a negative 3 is a negative 6. So there we've done 4 things. First, outer, inner, and last. And the last thing, the 5th thing to do, is to add together these 2 terms in the middle. Many times there's terms in the middle, not always, that you can add together. So this is x squared minus 1x minus 6. So this is multiplying polynomials. In this case, it's multiplying binomials. When you have binomials, you can use this technique called FOIL. Let's do another one, a little harder one, okay? All right, here are 2 binomials, and we're going to FOIL these because a binomial times a binomial, there's going to be FOI and L. Now, just a reminder again, what you can't do is just multiply the x terms together and just multiply the numbers together. This is not equal to 10x squared minus 32. It's not. We have to do 4 things, not just the like terms here. That's not the right answer. Okay? So let's FOIL it. F-O-I-L. Here we go. First terms. There's 2x and 5x. That's 10x squared. Outer would be 5x and 8. Positive 8. That's 40x. Inner would be negative 4 and 2x. That's a negative 8x. And then last would be negative 4 times 8, or a negative 32. Now once again, the middle terms can be added together. So I got 40 minus 8 is 32x. Okay? That's the method. 4 things to do. You got to do 4 things here. And then the last thing, one more thing to do, and that is to add these together. Multiply, 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 then add. Okay? Again, multiply, 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 then add. It's always done that way in FOILing. All right, not all problems are binomials. Let's look at one that's a little bit more complicated. All right, let's take a look at this one. You'll notice that we have a binomial and a trinomial. Now, the same idea applies, except for using FOIL, 4 things to do. We're going to have 6 plus 1 thing to do. That's because there's 2 items here, and there's 3 items here. I'm going to multiply every item here times every other item over here. So if I showed you a diagram, it would look like this. Take the first one here times the first one. First times the second. First times the third. Then I'll do the same thing. Second times first. Second times second. Second times third. You'll notice that I'm following a kind of a left to right attitude here as I do this. So here we go. 4x times 2x squared, that's 8x squared. Then I'm still sticking with 4x here. 4x times negative 5x is a negative 20. I'm sorry, that was incorrect there. 4x times 2x squared is 8x cubed. Yeah. 4x times 2x squared is 8x cubed. Sorry. 4x times a negative 5x is a negative 20x squared. 4x times 3 is 12x. Okay? As you can see, if I keep doing this, I'm going to run out of room over here. That makes for a very important technique that we can use that allows us to actually stack up the like terms. So the next three we're going to stack them up. So I'm starting with 9 now. I'm all done with 4x. 9 times each of these. So 9 times 2x squared is 18x squared. Well, I'm going to put it right underneath the other x squared term, 18x squared. And in the end, I'm going to end up adding up this because they're like terms. All right, 9 times negative 5x is a negative 45x. And 9, notice I put it underneath the x term there. And 9 times 3 is 27. What's going to happen is you're going to do the first line, and then the second line will be staggered. It'll start staggered a little bit, and so that things are still stacked up properly. All right, so we did 6 things. 1, 2, 3, 4, 5, 6. And then we're going to add up the like terms here. So let's add these up. And there's nobody going with x cubed there. This is nice because we've already got them kind of collected. We just have to add them. Negative 20x squared and 18x squared is a negative 2x squared. 12x and negative 45x is a negative 33x. And then bring down the 27. It did added to nothing. So after you've done 1, 2 times 3, 2 times 3 is 6 items, then your last step is always going to be to add them together. Some of them will get added, some of them, of course, won't. Remember, you're adding like terms. Let's try another one, but this time let's do a 3 by 3. All right. Again, we're multiplying together every item in this group times every item in this group. So 2b squared is going to get multiplied times all 3 of these. 7b is going to get multiplied times all 3 of these. And 9 is going to get multiplied times all 3 of these. And I can quickly figure out how many terms I'm going to get by noting that there's 3 here, and there's 3 here. 3 times 3 is 9. I should get 9 terms when I multiply these together. And I'm going to do this again, kind of working in a left to right fashion. So we're going to start here. I'm going to put my finger on this one. I'm not going to move my finger until I'm done multiplying times all 3 of these. Here we go. 2b squared times b squared is 2b to the 4th. I added the exponents there. 2b squared times 3b is 6b to the 3rd. And 2b squared times a negative 1 is negative 2b squared. All right, I've done this one times all 3. Let's move my finger over. Now 7b times each of these. 7b times b squared is 7b cubed. Well, b cubed is in this column, so I'm going to put it in this column. 7b cubed. 7b times 3b is 21b squared. Again, I'm putting it in the same column. And 7b times a negative 1 is a negative 7b. All right, we're done with all the 7b's. Now we're going to move with the finger to the next one. 9 times b squared is 9b squared. Well, where's it going to go? It's going to go in the b squared column. And again, you'll notice we're staggering this as we go across here. 9 times 3b is 27b. And 9 times negative 1 is negative 9. Notice how little room we actually used up. Plus, we got these stacked up so that we can add them easily. B cubes and the b squareds and the b's, they'll each get added in their own columns. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9 things we did. Now we predicted that. 3 times 3. All right, let's just add these up now. 2b to the 4th plus 13b to the 3rd plus, well, let's see, there's 30. And 21 and 9 is 30, minus 2 would be 28b squared. 27 minus 7 would be 20b minus 9. You'll notice they're written in descending order, which is kind of what we hoped that they would do. Now this is called multiplying polynomials, and remember, we're using the distributive property everywhere here. You can't just multiply the first item times the first item and the second item times the second item. We have to distribute it to all of them. That's kind of the central point of this assignment. Now, if you need to, go back and watch this again, kind of get an idea of what's happening here. Let's take a look at some of the word problems. All right, let's take a look at a problem with a picture here, a little geometry problem. This is problem number 12 from your book. The questions ask for us to come up with a representation, a polynomial representation, an expression for the area of this shape. Well, this shape is a triangle, and the area of a triangle is that formula that you can find in the back of your book. It's 1/2 b times h. B is the base. This is the base here. And h is the height. This one's the height. The height is always standing up straight, perpendicular to the base. There's another formula that you could use. I like this one better. It's base times height divided by 2. And either way you do it, you should get the right answer. I'm going to use this lower formula. You can see that taking half of something is the same as dividing by 2. So here we go. We're going to take the area is the base. Now notice I've got to put this in parentheses, times the height, and divide that by 2. Now before I can simplify this, I'm going to have to FOIL the top here. So let's go ahead and FOIL it. I'm going to move over here a little bit. 2x times 3x is 6x squared. 2x times -1, this is outside, -2x. Inner, 3 times 3x is 9x. 3 times -1 is -3. If we combine like terms, and because I'm short on room here, I'm just going to go 6x squared to the side plus 7x minus 3. Now what I failed to do here is to divide by 2. Well, I'm going to do that right here. And if I can divide by 2, I could leave my answer this way, which is certainly fine. This is an okay answer. Why are we dividing by 2? Well, it's because that's part of the formula. I could divide that 2 into all of these, but I end up with some fractions here, and it's just going to make the problem a little messier. You might see that in your book where they've divided that 3 into all 3 places here, but it's not necessary. Let's look at another one. All right, let's take a look at this one. Problem asks us to find the area. And you'll notice, if you remember from your work with geometry, that this is a trapezoid. And to find the area of a trapezoid, there is a formula for that. That formula is the area is 1/2 the height times the sum of the two bases. We'll just write them this way, base 1 plus base 2. The bases are the parallel sides. So this is a base here, and this is a base. We'll call this base 1 and base 2. And then this is the height because it's perpendicular to these bases. So let's stick all of these things in with lots of parentheses. So here we go. The area is 1/2 the height, 5x minus 8, times the sum of the bases, 2x plus 1 plus x plus 7. I've got two bases here. There's one and there's the other. 2x, oh, I'm sorry, that's 2x minus 1, isn't it? 2x minus 1 and x plus 7. The sum of the bases. So here's the height times the sum of the bases. I'm adding the two bases together. Now, we should add these bases first before we try to multiply. So we're going to go ahead and add those. And this is stepping back a couple of days to talk about combining like terms. We're adding, so we're going to just combine like terms. 2x times, or plus x, now we're adding, is 3x. And 7 and a negative 1 is 6. So when I combine these two by addition, see there's addition here, I'm going to get 3x plus 6. Now we're going to go ahead and FOIL this. Okay? Let's leave the half out for now. Just too much work, too distracting to try to multiply it. We'll do it at the end. Here we go. 1/2, just going to leave that. And this is 5x times 3x is 15x squared. Outer, 6 times 5x is 30x. Inner, negative 8 times 3x is a negative 24x. And last is negative 8 times 6 is a negative 48. I need to combine these inside terms here, the two middle terms. 3x and a negative 4x is 6x minus 48. So there's our area, and we could write the answer this way, which isn't bad, but if we distributed that 1/2 in, that might be better the way the book will write the answer here. So let's distribute that in. 1/2 times 15, that's 7.5 x squared. 1/2 times 6 is 3. And 1/2 times negative 48 is negative 24. And I think that's probably the way the book's going to write your answer. Of course, I didn't do this on the last problem, but this is about areas, so we're going to have to say units squared, okay, on our answer. So these problems that you have area on, this is the same process. You may need to go to the back of the book to find those formulas. Let's try another word problem. Okay, let's take a look at problems 45, 46, and 47. And these are problems that you're going to have on tomorrow night's assignment, 45, 46, and 47. Let's take a look at 45. It says, for exercises 45 to 47, consider 3 consecutive integers. Well, if you remember, consecutive integers are one right after the other, like 1, 2, and 3, or 6, 7, and 8. They're consecutive. I want 3 consecutive integers. Let the least of these integers be a. So we're going to let the first one be a. Do you remember what we did for the second one? Well, that's right. We added 1 to the first one. So if the first one is a, the second one would be a plus 1. And then the third one would be one more than that, which is a plus 2. Number 45 says, write a polynomial expression expressing the product of these 3 integers. Let's go to the whiteboard here. Okay, once again, we're going to let a be equal to the first integer. If there are 3 consecutive integers, the second one would have to be one more than that, a plus 1. And the third one would have to be one more than that, or a plus 1, or a plus 2. So there are my 3 integers. Now if you're looking in your book, question number 45 says, write a polynomial representing the product of these 3. Product? Well, that means I'm going to multiply them together. So I'm going to take a and multiply it times a plus 1. Notice I'm putting it in parentheses. And a plus 2 is the third one. Now, that would be an okay answer, but I get the feeling they want us to go ahead and multiply these out. So we're going to do that. And we could do it any way we wanted to. We could multiply the first one times the second one, come up with something, and then multiply times the third one. Or we could multiply any 2 of them together and then multiply the third one. I'm going to start with these 2 here. Okay? I'm going to start with these. So let's go a times a is a squared. We'll come back and deal with this a later here. Okay? A times a is a squared. Outer would be a plus a times 2 is 2a. Inner would be 1a. And last would be 2. Or I get a squared plus 3a plus 2. Remember, when we're adding, we have to have like terms, and we don't do anything with the exponents or the variables. Okay? Now, if I move that a down the page, now it's just a matter of distributing this monomial in. So a times a squared is a to the third. A times 3a is 3a squared. And a times 2 is 2a. Now, I want you to notice that there's our answer, but we could have actually multiplied any two of these together and then multiplied the third one. So don't multiply it in times both of them. Don't distribute it into both of them. You want to multiply two of them together and then multiply the third one. Why is that so? Well, if I took the numbers, let's say 3 times 4 times 5, I can go 12 times 5 is 60, or I can go 20 times 3 is 60, or I can go 15 times 4 is 60. But I'm not going to distribute that 3 into both of these. So it's not 12 times 15, it's 12 times 5. So again, that would be the answer to number 45. Let's take a look at number 46. Now, number 46 is doing a hypothetical, and everybody in the room is going to do it differently. Everybody that's doing these problems will do it differently. It says, choose an integer for a and find their product. Well, let's just pick. We're going to pick, I don't know, just to make it easy, let's just pick a is 2. That means a plus 1 would be 3, and a plus 2 would be 2 more than that, or 4. So I've just picked a to be 2, but you could have picked it to be any number you wanted to. Let's just pick 2. 2 times 3 is 6, and then it says find their product. So 2 times 3 is 6, times 4 is 24. If I multiply all of those together, I get 24. Now what happens if we go ahead and put those into our formulas here? Okay, let's take 2 and stick it in here, and here, and here. Let's see what happens. A to the third, or 2 to the third, plus 3 times 2 to the second, plus 2 times 2. I just tucked 2 into all three of these spots here. It says evaluate. Now we're on problem 47. This was number 46 here. Number 47 says evaluate the polynomial for the value a. So you just plug that 2 into all three spots. 2 cubed plus 3 times 2 squared plus 2 times 2. Well, 2 cubed is 8. 2 squared is 4. 2 times 2 is 4, times 3 is 12. Remember, you got to do exponents before you multiply. And 2 times 2 is 4. Well, what do I get? 8 and 12 is 20. 20 plus 4 is 24. Oh, look, it's the same answer we got over here. So we did it correctly. We did the polynomial correctly, and if you'd have picked a different number and plugged that into, it would have worked as well. So this is what you're going to be practicing tonight. You're going to have 2 nights to work on this. Make sure you spend a lot of time on this. This is a critical part of doing the future of algebra in factoring. Let's take a look at your homework. All right, here's your homework for the next 2 nights. Page 455, there's some problems that we've done and a few more there. And then number 44 is the same page. You've got some word problems. Make sure you practice all of these problems. Okay, very important. We're going to have a test coming up shortly. Be sure to check your schedule and out on Canvas to find the Zoom meetings out there. There's a required Zoom meeting every Wednesday. We're going to touch base to see if anybody has any questions about how to do anything. And then there's an optional Zoom tutoring session on Friday. We've got one at 11 and another one at 11:30. So you can show up to either one of those if you want. Okay? So we have a test coming up, and the test, let's see, that test is going to be coming up on May the 6th. Okay? The test is going to be on Canvas on May the 6th. You're going to be taking it at 7 o'clock at night. Okay? The test is May the 6th, 7 o'clock at night, and you can't miss that. Okay? So if you have any questions, you can email me, and I'll see if I can set up a Zoom meeting with you. Get that homework done, and then we'll move on to the next section. Take care.